Deep in the Arizona desert, the Vatican Observatory operates one of the most sophisticated astronomical instruments in the world. The Vatican Advanced Technology Telescope, a Gregorian telescope observing in optical and infrared on Mount Graham. Jesuit priests are conducting cutting-edge space research with mirrors that are among the most exact surfaces ever made for a ground-based telescope, challenging every assumption about the relationship between faith and science. The Vatican's astronomical work isn't some recent publicity move. It's one of the oldest active astronomical observatories in the world, with its roots going back to 1582 and the Gregorian reform of the calendar. When Pope Gregory XIII established a committee to study the scientific data and implications involved in the reform of the calendar, he was launching what would become a 444-year tradition of serious Catholic space research. The scale of this historical commitment becomes clear when you trace the timeline. In the mid-19th century, Father Angelo Secchi, a Jesuit at the Roman College, became the first to classify stars according to their spectra, a technique that remains fundamental to modern astronomy today. The Vatican also pioneered the Carte du Ciel, the first photographic survey of the whole sky, created in conjunction with 19 other observatories around the world, with results still being used as baseline data for modern surveys like Gaia. By 1891, Pope Leo XIII formally refounded the Specula Vaticana, Vatican Observatory, and located it on a hillside behind the dome of St. Peter's Basilica. This wasn't symbolic, it was operational. Sisters Emilia Ponsoni, Regina Colombo, Concetta Finardi, and Luigi Pancheri helped map and catalog nearly 500,000 stars as part of the International Carte du Ciel project, demonstrating the Church's institutional commitment to serious observational work. When light pollution from Rome's growth made observations impossible, the Vatican didn't abandon the work. They moved it. Twice. Pope Pius XI relocated the observatory to Castel Gandolfo, 25 kilometers southeast of Rome, in the 1930s. Then when that location became too bright, in 1981, the observatory founded a second research center, the Vatican Observatory Research Group, VORG, in Tucson, Arizona, one of the world's largest and most modern centers for observational astronomy. Today, the Vatican Observatory operates with the same institutional backing that built St. Peter's Basilica. A dozen priests and brothers, Jesuits and diocesan clergy from 4 continents conduct research using modern scientific methods. What started as calendar reform has evolved into something far more ambitious, a centuries-long investigation into the fundamental nature of space itself. The Vatican Observatory's current research portfolio reveals the sophisticated scope of their scientific work. Their 2025 annual report spans 108 pages, documenting research that extends far beyond what most people imagine when they think of Vatican science. The observatory's priest astronomers are conducting cutting-edge research in 4 major areas that mirror the most advanced work being done at secular institutions. Their 2025 summer school focused on major James Webb Space Telescope results covering first light and reionization, assembly and evolution of galaxies, birth of stars and protoplanetary systems, and planetary systems in the origin of life. These are not theoretical discussions. They're hands-on research programs where Vatican scientists are analyzing the same data that's revolutionizing astronomy worldwide. The observatory maintains one of the major meteorite collections in the world, with over 1,100 samples of more than 500 different falls, representing nearly 150 kilograms of extraterrestrial material. The collection includes historically significant specimens like a piece of the Martian meteorite Nakla that has been handled by popes. Vatican scientists have spent the past 15 years surveying the physical properties of meteorites, measuring density, porosity, and magnetic susceptibility, with current work developing techniques for thermal property measurements. The research extends to active planetary science projects. A Fireball Network project is underway in Tucson, with NASA providing 4 all-sky cameras to track meteors from atmospheric entry to meteorite recovery. Vatican scientists are applying their meteorite measurement techniques to lunar samples and Martian meteorites, contributing to our understanding of the Moon and Mars. These are peer-reviewed research programs conducted by priests with advanced degrees from top universities, publishing in the same journals and collaborating with the same institutions as their secular counterparts. Given that Vatican scientists are analyzing the same James Webb Telescope data and handling actual Martian meteorites that popes have touched, do you think religious institutions should be leading space research? Or does this mixing of faith and science make you uncomfortable? Let me know in the comments below. But the Vatican's space work goes deeper than meteorites and telescope data. 3 decades after the Vatican established their research partnership with the University of Arizona, the technical sophistication of their astronomical infrastructure has reached extraordinary levels. The Vatican Advanced Technology Telescope operates as part of the Mount Graham International Observatory in partnership with the University of Arizona, but the scope of this collaboration extends far beyond sharing telescope time. The primary mirror was manufactured at the University of Arizona's Stewart Observatory Mirror Laboratory, which pioneered both the spin casting and the stressed lap polishing techniques, which are being used for telescope mirrors that include the 6.5-meter aperture MMT in Magellan telescopes and the two 8.4-meter mirrors of the Large Binocular Telescope. The Vatican's telescope shares the same mirror technology as some of the most advanced ground-based observatories in the world. The technical specifications reveal just how cutting-edge this instrument is. The VATT's mirror is unusually fast at f1, which means that its focal distance is equal to its diameter. Because it has such a short focal length, a Gregorian design could be employed which uses a concave secondary mirror at a point beyond the primary focus. This allows unusually sharp focusing across the field of view. Given its excellent optical qualities, the telescope has been used primarily for imaging and photometric work, in which it regularly outperforms much larger telescopes located elsewhere. The operational structure demonstrates how deeply integrated Vatican astronomers are within mainstream scientific institutions. Both observing time and responsibility for VAT are shared with the University of Arizona on a 75% Vorg, 25% Arizona basis. This isn't a symbolic partnership. Vatican scientists control 3/4 of the observation time on a telescope that costs $4 million to construct and operates with the same technical standards as major university observatories. The recent automation upgrade reveals the Vatican's commitment to staying at the technological forefront. In 2024, the VATT received a complete automation system that allows astronomers at the Vatican Observatory in Castel Gandolfo outside of Rome to control the VATT remotely from across the world. The system enables not just remote operation, but fully automated observation sequences where the telescope can execute complex research programs without direct human oversight. Among the results from this telescope have been the discovery of macos in the Andromeda Galaxy, the validation of the Stromville photometric filter system, evidence for how the shape and dimensions of galaxies have changed over the age of the universe, discovery of the first binary Vesta chip asteroid, and the characterization and classification by visible colors of some 100 trans-Neptunian objects, most of them fainter than magnitude 21. These discoveries place Vatican astronomers at the center of major astronomical research programs, not on the periphery. What emerges is a picture of Vatican scientists as full partners in the international astronomical community, operating with the same technical capabilities and producing research that advances the fundamental understanding of the universe alongside their secular colleagues. The Vatican's official theological positions on extraterrestrial life reveal how deeply their space research connects to fundamental questions about creation and human identity. Brother Guy Consolmagno, the former director of the Vatican Observatory, and his predecessor, Father José Gabriel Funes, have publicly stated that believing in the possibility of alien life does not conflict with Catholic faith or doctrine. They emphasize that extraterrestrials, if they exist, would be part of God's creation and subject to the same divine love and providence as all other creatures. In 2008, Father Funes publicly stated that belief in extraterrestrial life does not contradict Catholic doctrine. He referred to hypothetical extraterrestrials as our brothers within God's creation and argued that humanity cannot place limits on God's creative freedom. Brother Consolmagno, one of the Church's most recognizable scientific voices, further developed this position when he stated he would baptize an extraterrestrial if they asked, a comment that crystallized the Vatican's institutional openness to the theological implications of discovery. These positions emerged from formal Vatican conferences on astrobiology, where dozens of scientists, including non-Catholics from the US, France, Britain, Switzerland, Italy, and Chile, gathered to explore whether sentient life forms exist on other worlds. The Vatican's theological framework addresses the most profound questions that would arise from contact with intelligent aliens. When asked whether God would have to be incarnated elsewhere if there were intelligent life on another planet, Father Funes recalled the parable of the lost sheep. God's incarnation in Jesus Christ was a singular and unique event not only in human history, but in the history of the universe and the cosmos, he explained. The existence of evil and original sin on earth meant God, the Good Shepherd, had to leave behind his entire flock to retrieve his one lost sheep, humanity, through incarnation as Jesus. The Vatican's astrobiology research extends beyond theological discussion into active scientific collaboration. Vatican scientists participate in the same research networks and conferences as secular astrobiologists, contributing to the scientific search for life, while simultaneously developing theological frameworks for what discovery would mean for human understanding of our place in creation. This dual engagement, rigorous science paired with explicit theological reflection, distinguishes the Vatican's approach from secular institutions and reveals how their centuries-long commitment to astronomy has evolved into a sophisticated model for integrating faith and empirical investigation. What emerges from this centuries-long commitment to astronomical research is something far more profound than an institution that simply accommodates science. The Vatican Observatory has become a pioneering model for how humanity might approach the cosmos in the decades ahead. In 2025, the Vatican Observatory partnered with Johns Hopkins University and the Space Telescope Science Institute to launch Wonderbound, an exhibition featuring cosmic imagery from the Hubble and James Webb Space Telescopes, demonstrating how their approach integrates cutting-edge science with broader questions about human meaning and purpose. The Vatican's perspective on space exploration reflects their institutional approach. They are especially concerned about the pollution of pristine environments in space and the great risk of increasing space debris, while being particularly vociferous about international treaties and regulations of space use and travel that need to be put in place to ensure peace, justice, and that benefits reach all. On April 29, 2026, the Vatican Observatory announced that 4 asteroids have been named in honor of important figures in the observatory's history, including Pope Leo XIII, continuing the Pope's intention to support science and show the world and the Church that faith and science go together. This symbolic recognition in space itself represents how the Vatican's model has evolved, from calendar reform in 1582 to having their institutional legacy literally orbiting in the cosmos. The Vatican Observatory's 2027 Summer School will focus on the late stages of stellar evolution, described as standing at the frontier of modern astrophysics, a domain where extreme physics, complex chemistry, and transformative processes converge, with the dawn of a new observational era defined by JWST and the Roman Space Telescope bringing unprecedented opportunity. Their research agenda extends decades into the future, positioning Vatican scientists as leaders in understanding how galaxies assemble across cosmic time. The Vatican Observatory's budget makes up about 0.5% of Vatican City-State's total annual budget, about the same proportion as NASA's budget in the U.S. government. But since observatory members are Jesuit priests and brothers living under vows of poverty, this money supports far more research than would be possible at a traditional observatory. This economic model suggests how institutions might sustain long-term scientific research without the competitive pressures that often drive shorter-term thinking in secular science. What the Vatican Observatory ultimately represents is a template for approaching the cosmos that combines rigorous empirical investigation with explicit reflection on meaning, purpose, and humanity's responsibility as explorers. Their work suggests that as humanity expands into space, we need institutions that can hold both scientific excellence and deeper questions about our place in creation, not as competing priorities, but as complementary dimensions of a mature cosmic civilization. After 444 years of continuous astronomical research, the Vatican has demonstrated that the most profound questions about the universe require both telescopes and wisdom, both data and contemplation, both discovery and humility. Subscribe for more hidden scientific institutions and watch this one next. It goes even deeper.